This is an example that will show you how to use the constant acceleration equations. A block with initial velocity 5 meters per second slides up a ramp, stops momentarily, and slides back down. The block accelerates at a constant rate of 4 meters per second squared down the incline. You can probably imagine what this motion looks like, but here's a simulation that shows it to you. Now, there are lots of questions that we can ask about this motion, but here are a few examples. How far does the block travel before stopping? How long does it take the block to return to the starting point? What's the velocity of the block when it returns to the starting point? And how long does it take the block to reach the end of the ramp, which is 3 meters below the starting point? You probably won't be surprised to hear that we're going to be using the constant acceleration equations. After all, the problem states that the acceleration is 4 meters per second squared down the incline. But let's just take a minute to double check that this really is constant acceleration. So here's the motion again. This time I've labeled direction. So we're going to say that up the incline is positive and down the incline is negative. And take a minute to think about what the velocity versus time graph would look like as you watch this motion. And then I'll show it to you again, and this time I'll fill in the velocity versus time graph as we go. And you can see that velocity versus time is a straight line. And so it has a constant slope. And the slope of velocity versus time is acceleration. And so this is an example of constant acceleration. So we're in good shape, and we can use the constant acceleration equations. So now getting back to the problem, let's start with how far does the block travel before stopping. The general approach to these constant acceleration equations is just to think about what you're looking for, what information you have, and to pick the best equation out of the list. So we're looking for change in position. We want to know how far the block travels before stopping. We don't know how long that's going to take, but we were given that the acceleration is 4 meters per second squared down the incline, and by the way I've chosen my directions, that means that the acceleration is negative 4 meters per second squared. We also know the initial velocity is 5 meters per second, and if we're looking to determine how far the block travels before stopping, then the final velocity will be 0 in that case. So we want to know delta x. We know these other 3 variables, and now it's time to just look in the list of equations and to pick the one that has those 4 variables. Or another way of thinking about it is we can look for the equation that doesn't have delta t in it. So this is the best choice. Rewrite the equation, plug in the information that you have, and solve for x, 3.1 meters. On to the next part. How long does it take the block to return to the starting point? Well, this time we know that the change in position if the block is returning to the starting point would be 0. We don't know the time, that's what we're looking for. We know the acceleration is minus 4 meters per second squared, the initial velocity is 5 meters per second, and for the moment we don't know what the final velocity is. So once again, we're looking for this variable. We have these 3 variables, and we need to look for an equation in the list that has the 4 variables we're interested in, or that doesn't have VF. And this is the best choice. Rewrite it, plug in. Now this time we have a delta t and a delta t squared. So after dressing the equation up a little bit, you can see that it factors, and you get 2 answers. Delta t is equal to 0 and delta t is equal to 2.5 seconds. Delta t is going to be equal to 0 at the very beginning because the object is at the origin at t equals 0. The object then slides up the incline and comes back to the origin at delta t is equal to 2.5 seconds. And so we don't want the first answer, and we do want the answer delta t is equal to 2.5. What is the velocity of the block when it returns to the starting point? Well, this time we know, again, that delta x will be equal to 0 when the block returns to the starting point. We did determine the time that that takes in the previous part, but for the moment, let's not use that information, even though we have it. We know that the acceleration is minus 4 meters per second squared. The initial velocity is 5 meters per second. And we're looking for the final velocity of the block when it returns to the starting point. So we want this. We have these other three. We're looking for the equation that involves delta x, a, vi, and vf. This is the best choice. And because delta x is 0, the term 2a delta x is 0, which means that vf squared is equal to vi squared, which means that vf is plus or minus vi. And of course, we know that when the block returns to the starting point, it is moving in the negative direction. And so that means that vf is equal to minus vi, or minus 5 meters per second. Okay, finally, how long does it take the block to reach the end of the ramp 3 meters below the starting point? Well, we have to be a little bit careful here. What is delta x going to be in this case? You might think just 3 meters, but you have to be careful. Down the incline, we've defined to be negative, and so if the block is below the starting point, then delta x needs to be written as minus 3 meters. We don't know the time. That's what we're looking for. We know the acceleration. We know the initial velocity. We don't know the final velocity. So that's what we're looking for. These are the things we know. Look for an equation that does not involve VF or that does involve the other four. It's this one. And we can plug in and solve. Here again, we have an equation that's quadratic in delta t, and so we get two answers. Delta t is equal to 3 seconds, and delta t is equal to minus 0.5 seconds. We're going to get rid of the negative answer. We are looking for a positive value for delta t because we're assuming that this whole thing starts when time is equal to 0. But you can think about the physical meaning of the negative 0.5 seconds. If you imagine the movie that involves the block sliding up the ramp and then sliding back down, well, that started at t equals 0 and the block had an initial velocity at that time. If you imagine letting the movie run in reverse to some time before 0, there would be a moment at t equals minus 0.5 seconds when the block would be gliding up the incline at 5 meters per second. So we're not going to take that answer, but it does have an interesting meaning. So that's it for this problem. And as long as you have a situation with constant acceleration, this is the general approach to solving these problems.